The communication between NuMaker Brick modules works like this. The master module calls on the slave modules via I2C. And when the slave modules receive the command, it will send its collected data back to the master. So when the vibration module and the buzzer module have been called upon, they will both feedback their information collected on the sensor nodes back to the master. In order to communicate with the sensor, the NuMaker Brick classifies data into 3 categories. First is the output data. When the master sends information to the slave, the sensor on the slave end will identify whether the data is an input or an output data. Next is the input data. When the slave sends data back to the master, that information will be classified as input data. Third one is the feature data. If the sensor acquired data that is not often sent or received, it will be classified as feature data. While the 9 sensors provided by the NuMaker Brick can fulfill most demands, we do not want to set any limit to your creations. Therefore, we're going to show you how to add a new device with the previously mentioned extension module. In this section of the video, we will introduce the photoresistor sensor module, how it works, and how to add this new sensor to the NuMaker Brick step by step. We will now give you an introduction of the new sensor module. The photoresistor introduction includes its hardware, software, and the firmware. The software introduction is further divided into 2 parts: how the photoresistor sensor works, and how will the master respond to it. We will take a minute to check out the extension board's hardware. Here you can see the circuits. On its left is a general purpose board with no wiring, so that any components could be placed here. The 5V mark on the top stands for 5V power supply. The right hand side supports 3.3V power supply. The G and D on the bottom stands for ground. With these, the configuration of power supply should be quite easy. A high-performance M452 series microcontroller is embedded, and it supports many features. Full function pin out is also provided to allow more flexibility in designs. Like all the other sensor modules, the extension board also comes with a power indicator, reset pin, plus a USB connector. While all these may seem confusing in the beginning, adding a photoresistor function to the NuMaker Brick's extension board is probably easier than what you have imagined. Please take a look at the circuit diagram again. The photoresistor circuit is actually quite simple. All we have to do is pull out the PB0 pin from the MCU, connect it to VDD through 3.3K, then connect the photoresistor to GND, and you're done with the hardware setup. This is an example of the photoresistor circuit. We can see a 5V current go through the photoresistor and then through another resistor to the ground after receiving to ADC. Moving on to the photoresistor programming. In the main program, the program is divided into 3 parts. The first part is module initialization, which executes when the module initializes. For example, the photoresistor will perform ADC initialization in LR_INIT. Next is the execution cycle program, and this is where the program executes, including non-periodic executions. Each module may need to detect or to receive. This is where the functions are placed. We can see the photoresistor program inside the rectangular box, LR_INIT.C. This is its initialization. Gate LR.C is the program of the photoresistor to capture value. This video has 4 parts. This is part 3. Please proceed to the next video.